Latest Machine Learning Algorithms 2025. In the rapidly evolving landscape of artificial intelligence, machine learning algorithms have become pivotal in driving innovation across industries. As we step into 2025, new developments in these algorithms are not only enhancing existing applications but also opening doors to novel possibilities previously deemed unattainable. The advancements made over recent years reflect a growing sophistication in handling complex datasets and improving model accuracy. These innovations are reshaping how organizations approach problem-solving through predictive analytics, automated decision-making systems, and personalized user experiences. Understanding modern machine learning frameworks form the backbone of any AI implementation, providing essential tools for developing, training, and deploying models efficiently. In 2025, there has been significant evolution towards more modular architectures that allow developers greater flexibility and customization options tailored specifically for their application needs. A key trend observed is an increased emphasis on integration capabilities between different platforms. This enables seamless interoperability among various components involved in building intelligent solutions without being constrained by proprietary limitations inherent in older framework designs. Modular architecture allows individual modules such as pre-processing pipelines or optimization layers to be swapped out easily depending on project requirements. Cross-platform compatibility facilitates deployment across diverse environments including cloud services, edge devices, and mobile platforms without compromising performance metrics. Furthermore, improvements in documentation quality coupled with active developer communities contribute significantly to faster prototyping cycles while reducing overall development timeframes associated with adopting new technologies. This shift underscores a broader movement within the tech industry toward democratizing access to powerful computational resources previously reserved for elite research institutions or well-funded enterprises. Supervised learning techniques reimagined. Despite its long-standing presence in academic circles, supervised learning remains at the forefront due largely to ongoing refinements aimed at increasing precision levels even under challenging conditions where data scarcity poses obstacles. One notable advancement involves enhancements in ensemble methods, particularly gradient boosting techniques, which now incorporate adaptive sampling strategies designed explicitly for imbalanced datasets common in real-world scenarios. These adjustments help mitigate biases introduced during initial phases of feature extraction, thereby ensuring better generalization properties when applying trained models against unseen test samples. An illustrative example can be found within financial fraud detection systems where traditional approaches often struggle with low incidence rates, yet improved variants show marked improvement in identifying suspicious transactions accurately while minimizing false positives. Unsupervised learning gains momentum with escalating volumes of unlabeled data becoming increasingly prevalent across sectors ranging from social media analytics to healthcare diagnostics. Unsupervised learning methodologies continue gaining prominence year after year. Recent breakthroughs include enhanced autoencoder implementations capable of capturing intricate patterns hidden within high-dimensional spaces typically encountered during image segmentation tasks or natural language processing endeavors. Moreover, clustering algorithms now leverage graph-based representations, enabling them to discern hierarchical structures embedded deep within vast repositories of interconnected information points. Such progressions enable analysts working with sparse textual corpuses, like scientific literature archives, to uncover latent thematic connections absent conventional keyword frequency analyses alone could detect. Reinforcement learning meets real-time applications as autonomous vehicle technology advances swiftly along parallel tracks alongside generative adversarial networks' maturity curve. Reinforcement learning emerges as critical enabler, allowing agents situated within dynamic environments make optimal decisions instantaneously based upon continuous feedback loops provided by sensory inputs received continuously. Dramatic reductions in simulation fidelity gaps achieved via photorealistic rendering engines paired with hardware accelerations offered through specialized tensor core units facilitate accelerated convergence times crucially needed before real-world deployments occur safely. Industry leaders investing heavily into robotics R&D programs report measurable gains in task execution reliability following incorporation of dual priority reward functions, prioritizing safety constraints first followed subsequently by efficiency considerations secondarily weighted accordingly according to operational parameters defined externally. Preliminary tests involving multi-agent coordination setups indicate promising potential towards realizing swarm intelligence behaviors reminiscent those exhibited naturally by insect colonies, albeit implemented digitally within controlled experimental settings intended solely for validation purposes initially until full-scale rollouts commence later stages. Federated learning revolutionizes privacy preservation, faced mounting regulatory pressures concerning personal identifiable information management practices, globally enforced stringent compliance mandates necessitating adoption of decentralized computing paradigms, ensuring sensitive dataset stays localized instead transported elsewhere, exposing vulnerabilities susceptible exploitation otherwise. Federated learning addresses precisely this concern via distributed architecture wherein model updates derived locally computed instances retained securely behind firewalled infrastructures shared collectively amongst participating entities, contributing towards collective knowledge base incrementally aggregated periodically post-validation checks completed successfully meeting predefined thresholds set forth collaboratively agreed standards beforehand established uniformly consistent manner. Notably, healthcare sector pioneers utilizing electronic medical records databases witness tangible benefits stemming from collaborative cross-institutional model training efforts resulting in universally applicable diagnostic assistance tools, surpassing institution-specific narrow scopes limited prior attempts isolated operations siloed facilities operating independently without recourse external partnerships beneficial mutual growth prospects aligned strategic objectives, harmonized interests, pursued concurrently synergistically reinforcing complementary strengths each other reinforcing outcomes exceeded expectations originating singular initiatives executed stand-alone without benefit network effect produced pooled resource utilization optimized efficiencies realized jointly attained milestones otherwise inconceivable individually. Educational institutions embarking onto similar trajectories observe analogous positive trends particularly regarding student performance prediction mechanisms benefiting substantially from pooling together longitudinal tracking data, normally fragmented dispersed across disparate administrative domains complicating holistic assessments attempting synthesize meaningful conclusions absent unified dataset readily accessible integrated system facilitating cross-sectional comparative analysis. Required generate actionable insights, inform policy formulations guiding future direction institutional developmental pathways planned accordingly. Explainable AI becomes mandatory requirement with growing scrutiny surrounding opaque nature black box models deployed mission-critical infrastructure requiring transparent interpretability guarantees necessary satisfy legal obligations, imposed jurisdictions demanding accountability. Traceability whenever adverse consequences arise attributable faulty predictions generated undetectable flaws embedded internal logic structures remained invisible observers unable ascertain precise causes leading problematic outputs, manifesting unexpectedly without prior warning signals. To comply mandated transparency protocols, researchers pioneering explainability toolkit development focus augmenting classical algorithmic constructs incorporating interpretable proxies surrogate models mimicking original counterparts sufficiently accurate produce comparable results maintain fidelity level desired benchmarks simultaneously offering clarity exposition elucidate rationale behind final determinations reached computational processes involved derivation ultimate output arrived conclusion arrived thereof. These modifications do not compromise accuracy figures appreciably nor degrade functional efficacy, primarily because explanatory components introduced intentionally decoupled from core inferencing machinery retaining autonomy. Independent operation unaffected interdependencies causing cascading failures propagated throughout entire pipeline undermining stability robustness expected reliable deployment contexts demanded production environments strictly regulated audited regularly evaluated. Compliance certifications acquired periodically renewed adhering current guidelines updated frequently accommodate emerging best practices evolved field advancing continuously pushing boundaries knowledge frontier ever expanding domain expertise Cultivated, sustained investment maintained consistently. Businesses integrating such features gain competitive advantage navigating compliance landscapes smoothly, avoiding costly litigation expenses incurred non-compliance situations, exposing negligence missteps lacking adequate safeguards, mitigating risks proactively rather passively, reacting aftermath damage already occurred irreparably. Quantum machine learning emerges from theoretical phase into practical implementation. Although once confined realm theoretical exploration, quantum mechanics principles applied machine learning disciplines gradually transition practical experimentation phase, yielding concrete demonstrations, validating feasibility concept, translating abstract mathematics actual working implementations, functioning correctly, achieving promised advantages traditionally elusive conventional digital computers. Constrained classical bit paradigm inherently limiting expressive power, available modeling highly entangled states, represented qubit superpositions, exponentially larger Hilbert space dimensions, inaccessible standard von Neumann architectures. Initial successes demonstrated variational quantum eigensolver algorithms, optimized parameterized ansatz, discovering ground state energies, molecular configurations, accurately compared empirical measurements, confirming correctness. Assertions bolstering confidence, further explorations pursuing expanded applications beyond chemical simulations, extending towards combinatorial optimization problems tackled formerly exact solution unavailable, tractable sizes. Approximated heuristics instead heuristic. Approximation techniques dominated approximation theory, bounds determined asymptotic behavior, growth function complexity classes, classified problem hardness levels, categorized polynomial versus exponential scaling differences, fundamentally altering understanding capabilities, limits cognitive capacities, human minds versus machines, engineered surpass innate abilities, biologically evolved organisms subjected same physical laws governing universe itself. Investment surges witnessed from both public-private sectors, fueling rapid expansion ecosystem encompassing hardware manufacturers constructing error-corrected processors, suitable enterprise-grade usage, coupled software providers supplying libraries, APIs enabling seamless interfacing, codebases, written legacy languages popular nowadays, Python, JavaScript, etc., thus lowering entry barriers, novice programmers eager explore burgeoning field acquiring requisite skills competencies relatively quickly without needing extensive background theoretical physics, usually prerequisite previous engagement field considered prohibitively difficult, daunting, intimidating, deterring would-be participants unless equipped. Sufficient preparation resources, guidance, mentorship opportunities adequately supported, encouraging wider participation, fostering inclusive culture, welcoming diversity backgrounds, talents, converging synergies, producing innovative ideas, solutions. Addressing pressing global challenges faced humanity today, tomorrow alike. Predictive maintenance systems employing quantum neural nets exemplify early-stage implementations delivering superior fault detection rates, detecting minute anomalies, undetected classic ML counterparts suffering from false negatives. Potentially catastrophic implications, industrial environments reliant uninterrupted operation, vital life-sustaining equipment operated continuously round-the-clock basis without respite, weekends, holidays whatsoever. Conclusion: the trajectory of machine learning algorithms in 2025 illustrates an era characterized by unprecedented fusion, interdisciplinary collaboration, propelling technological frontiers forward, redefining possibilities hitherto unimaginable few decades past. From enhanced privacy preservation techniques safeguarding sensitive information during distributed computing operations to quantum-enhanced models unlocking secrets nature herself had kept hidden millennia. Every facet showcases remarkable strides taken, united effort, scientific community dedicated, transforming hypothetical visions, tangible realities, impacting everyday lives profoundly across multifaceted aspects, modern society. Constructed upon bedrock foundational principles, computer science, engineering, mathematics, physics, biology, statistics, collectively forming grand edifice known artificial intelligence. For practitioners engaged actively within field, staying abreast latest developments imperative, cultivating adaptability, versatility, indispensable traits, thriving fast-paced environment demands constant reinvention, mastery, continually emerging tools, methodologies shaping future directions, discipline ahead. Embracing these innovations thoughtfully, mindful ethical implications ensures responsible stewardship, wielded transformative powers judiciously, balancing progress restraint, creating equitable societies benefiting all inhabitants regardless origin, status, privilege, lived experiences encountered throughout existence.